Dear learners, welcome back. That we have already completed class and object in Python, we are comfortable with the principles like abstraction and encapsulation in object oriented programming. Let us now dive a little deeper into the feature of encapsulation and identify the need for a special type of methods called the getters and setters. In fact, getters and setters are used in many object oriented programming languages, especially in Java to a large extent, to ensure that the principle of data encapsulation holds. They are also called mutator methods as well in some textbooks. By the way, can you recall what is data encapsulation? Well, let us have a quick review. We have learnt in our introduction session on object oriented programming that encapsulation is defined as the bundling of data with methods that operate on these data. These methods are, of course, the getter methods for retrieving the data and the setter methods for updating the data. According to the encapsulation principle, the attributes or properties of a class are made private in order to hide or protect them from unintentional or accidental access by other sections of code. Let us examine the Java style of writing a class. We have defined a class called P and it has a variable, a member called X, and two methods by the name get underscore x and set underscore x. We have already talked about this self object in our previous sessions. So, the first method is the init method, that is the constructor, a parameterized constructor that actually sets the value of x, and the second method is the getter method by the name get underscore x, which returns the value of x, and the third method, the set underscore x, is the method that sets a new value to the variable x. The variable x starts with 2 underscore, reminds you in Python that this is a private variable inside a class. And after the definition of the class P, now we have this we are instantiating two objects of class P by the name P1 and P2, wherein for P1 we set the value of x to 100 and for P2 we set the value of x to 500. So, now you want to access the value of x from P1, you have to go through the method getX, because the attribute x in class P is private. So, there is no way to access directly. So, you have to go get through the method getX to get the value. So, we call P1 dot getX. Similarly, now I want to change the value of this value of x in P1, object P1 to 1000. So, I have to go through the setX method. So, I say P1 dot setX to 1000, and now I print the value of x in P1. Okay. Now, you see that I perform a expression. So, what I do is I get the value of x from P1 and get the value of x from P2, add them up and set the value to x in P2. Okay. Now, just have a look at this program, and now we will run this program and see. Got it? You got the result. Okay. Okay. Having created two objects of class P, say P1 and P2, suppose you would like to write an expression using the value x of objects P1 and P2. Say you want to add, say P1 dot get underscore x plus P2 dot get underscore x. That is what we did in the example. Say for example, you want to add the contents of x in both objects P1 and P2, as we did in the example. So, what we did is we create an expression of the type p1 dot get underscore x plus p2 dot get underscore x. It looks clumsy, isn't it? Will it not look a whole better if we put it down in this form, like p1 dot x plus p2 dot x? That is a simple way. Such an expression is easier to write and easier to understand by a third person. Will you now redo the whole thing in a Python style? Okay. Now, here you see that we have redefined the class, but now I call this class p underscore 01, okay, to differentiate from the other class. So, it is a very simple class. I just created the class with a parameterized constructor, so which assigns the value of x to the variable. Here x is defined as public. Now, I create two objects p1 and p2, and the value of x in p1 is set to 500, the value of x in p2 is set to 1500. Now, I print the value of x in p1, and similarly now what I do, you see that instead of having a getter a setter method, I directly access the value of x from p1. I simply say p1 dot x, and here I simply assign a value 47 to p1 dot x. Then I write the expression p1 dot x is equal to p1 dot x plus p2 dot x. So, it's a lot simpler way of doing it when the variable x is public. Okay. Then I print the value of x. Now, let us run this program and see. Got it? You see the result. Okay. Oh, that looks much simpler, is it not? And it works also. But wait, where is the encapsulation gone? Yes, there is no encapsulation, and in this case we do not need it either. Generally, you want to create when you want to create modules in Python, you keep all the members intentionally public, so that they can be accessed by other user modules. However, unfortunately, it is a widespread belief that a proper Python class should encapsulate private attributes by using getters and setters. As soon as a programmer introduces a new attribute, he or she will make it a private variable and create automatically a getter and a setter method for this attribute. Some programmers may even use an editor or an integrated development environment called IDE, which automatically creates a getter and setter for all private attributes. Some of these tools even warn the programmer if he or she uses a public attribute. This certainly does upset Java programmers, since the Python style is to introduce attributes and make them public. Now comes the crux of the problem. What if we want to change the implementation in the future? Let us assume we want to change the implementation like this. The attribute x can have values between 0 and say 100. If a value larger than 100 is assigned, x should be set to 1000. Correspondingly, x should be set to 0 if the value is less than 0. Let us make this change in our example code and run it and see what happens. In this video, so you find that we are defining a class by the name p underscore 02. So, here what we are trying to do is we are trying to impose a condition on the values that this variable x can hold. Here in this example, we have taken the condition as x should be between 0 and 1000. So, if this is implemented in this set function. Okay. So, here is where the getter and setter are useful to us. So, you have the set function. In the set function, what we do, if the value of the x is less than 0, then we set the value of x equal to 0. If the value of x is greater than 1000, then we set the value equal to 1000. Other than that, for any other value between 0 and 1000, the value as it is assigned to the variable x. So, that is what the change we have made in the setter function called set underscore x. And here you come and see that we create an object p1 and here we set the value as 1000, 1001. So, what do you expect? We expect a value to be set as 1000 because this value is greater than 1000. And here for the object p2 we set a value 15, 0 and 1000. So, naturally the value 15 will be assigned, and for the object p3 we are assigning a value -1 which is less than 0. So, here the value of x for object p3 will be 0. So, that is what we expect from this code. So, let us run and see. Wonderful, this also works, but wait, there is a catch. Run these statements and check for yourself. Now, we have the same class definition as we have done before. This time I call it p underscore 03. So, this the same code. So, wherein the setter function checks for the value of the variable x. If it is less than 0, assigns 0. If it is greater than 1000, it assigns 1000, otherwise it assigns the value as it is to the private variable x. Now, what we do is, now here you see that we create an object p1, okay, and which is with a value 42. So, naturally the value will be 42, but here you see since this x is the private variable, okay. So, what we are trying to do here is we are trying to access x, okay, like p1 dot x. So, this is not accessible. So, see this is against the encapsulation principle, okay. So, what do you expect? So, here you cannot access the value of x, just run and see, got it. See, we have set a value 1000, but here you see the value is not assigned, okay. So, this is the catch. So, what do you infer from this exercise? Our new class breaks the interface. The attribute x is not available anymore. That is why in Java, Java programmers are recommended to use only private attributes with getters and setters, so that the implementation can be changed without having to change the interface. But the good news is Python offers a solution to this problem. It is called the properties. Let me demonstrate it with the same example. In this class, we are creating a new class called p underscore 04. Here you see that the first function, that is the init function, that is the constructor, there is no change in that. Then we have the second function called x, okay, which takes an object of itself, that is self, okay, and returns self dot underscore x, since x is a private variable. Now, in this case x is a private variable. Now, so we have used a decorator. You see this is called the decorator, this at the rate symbol, and we have another decorator here, x dot setter, this is another decorator. So, these two decorators are used in defining properties. So, there is a difference between property and a private variable, that will be made clear in the subsequent example. In this example, as far as the property is concerned, so here we define x as a property, okay. So, this x is a property. So, the setter method now manipulates this property, says if the same code, if x is less than 0, assign x 0 to x, else if x is greater than 1000, assign 1000 to x, or then if x is between 0 and 1000, then assign x as it is to x. So, this is what the code is, but only thing change what we have made here is the property, okay. We have used property instead of private variable. Now, here comes the application. Now, you see that we are creating an object p1 and we are assigning a value 10 to it. So, here we expect an answer 10, and next we assign a value larger value, but this time we are not we are just simply assigning, say we are calling it P1 dot x, we are accessing x as if it is a public member. Okay. So, we are saying P1 dot x equal to say 10,000. Okay. So, what do you expect here? We expect here as 1000, because the value 10,000 is greater than 1000. Okay. But in the previous case you see that this was not possible. Okay. Since the x was there it was defined as public, and that actually violated the encapsulation principle. Right. Now, let us run this program and see. Got it? You see? So, now you see the second line, here we get the value 1000. Okay. So, that means x can be accessed using the dot operator, okay, just like a public member, but x is not a public member, it is a property. Okay. So, the Python way of defining a setter function is the use of property, that is evident from this particular example. Okay. In this example, the lines @property and @x dot setter are called decorators. Even though there are other alternative syntax for defining properties, the use of decorator is the preferred Pythonic way of doing things. Before we conclude this session, let us get our hands dirty on a more realistic application of creating a robot called Chitty, and this robot has a property called mood. The mood of the robot depends upon two internal states. They are called attributes. One is feeling healthy and another one is feeling elated. These two attributes are really internal to the robot and need to be private. The attribute mood, which can be deduced from both feeling healthy and feeling elated, is fit to be deemed to be a property of the robot. The property mood in our example returns the mood of the robot in a descriptive string. The condition depends upon this sum of the values of feeling healthy and feeling elated of the robot. Now, here is the class for creating the robot named Chitty. Now, here you see that this robot has some variables called name, attributes, name of the robot, the year in which it was built, the build underscore year, and you see I have introduced two private variables, feeling healthy and feeling elated. So, these two variables are private, okay, and they cannot be accessed by outside this class, okay, and these are assigned a value of -1 to +1, okay, and here we define a property. Now, you see we define a property called mood. So, the mood is a property, whereas feeling healthy and feeling elated, they are private variables. Now, what is the difference? The difference is here the property mood is deduced from these two private variables, feeling healthy and feeling elated. So, what we do here is we simply sum them. We simply add feeling elated, see feeling elated and feeling healthy. We sum them and we assign it to a variable s, okay, and depending upon the values that of s, for example, if s is less than -1, I say the robot is feeling miserable. If it is between 0 and -1, then it is feeling bad. If it is less than 0.5 but greater than 0, it could be worse. If it is less than 1 but greater than 0.5, it seems to be okay. Else if it is greater than 1, the robot feels very great. So, this is the mood. So, this mood is a property, okay, which is derived from two private variables. Now, I think you can understand the difference between the property and private variables that is available in Python. Okay. So, this is a feature that Python has introduced, okay, which is not present in other object oriented programming languages. Now, here is the main function wherein I create two instances of the robot, one is x, another is y. The first robot is Chitty 1.0, the year made is 2009, and you see that I assigned a value of 0.2 to feeling healthy and minus 0.4 to feeling elated. So, naturally what will happen when you add these two, 0.2 plus minus 0.4 will be minus 0.2. So, minus 0.2 will be I feel bad, minus 0.2 will be I feel bad. Okay. Whereas, the second instance of the same robot y, I call it by the name Chitty 2.0 and the year made is 2018, and you see I assign a value 0.7 to feeling healthy and 0.7 to feeling elated. Okay. So, now when you simply add this 0.7 and 0.7 you get 1.4. So, 1.4 is greater than 1. So, it is great for this robot. Okay. So, this is what we expect from the running the code. Okay. Shall we run the code? Got it? You see the first Chitty 1.0 feels very bad, whereas Chitty 2.0 feels great. Okay. Now, I think you know the difference between what is a property and what is a private variable. Okay. We have reached the end of the module on getters and setters. It is time to summarize the usage of private and public attributes, getters and setters and properties. Let us assume that we are designing a new class and we are thinking about an instance or a class attribute, say our attribute, which we need for the design of our class. We have to observe with the following issues. Will the value of our attribute be needed by the possible users of our class? If not, can we or should we make it a private attribute? If it has to be accessed by the other users, why not make it accessible as a public attribute? Well, we will define it as a private attribute with the corresponding property if and only if we have to do some checks or transformations of our attribute, like what we did for the setting of value of x between 0 and 100. Alternatively, we could use a getter and a setter, but remember, using a property is the way of doing things in Python. See you then. Bye.